Hi everyone. Today we're going to compare and contrast dot product with cost product. Dot product and cost product both are operations on vectors. If the vector A is equal to A1, A2, A3, the vector B equal to B1, B2, B3, then A dot B, the dot product of these two vectors, is equal to A1 times B1, adding A2 times B2, adding A3 times B3. The result here is a real number, or we call that a scalar. And the cost product, we can write the cost product as this symbolic determinant. And when we expand this, we got the result as this vector here. The result of the cross product of these two vectors is again a vector. So the first difference between dot product and cost product is the result of a dot product is a scalar. The result of a cost product is a vector. And for this reason, we also call a dot product a scalar product. And the cost product is also called the vector product. So these are the first two differences between dot product and cost product. They have different definition, they have different results, and they also have these two different names. For A dot B, if you look at the picture, if theta is the angle between the two vectors, then A dot B is equal to the product of the magnitude of A times the magnitude of B times cosine theta. For cost product, the right-hand rule gives the direction of A cos B. And if theta is the angle between these two vectors, then the cost product, the magnitude of this cost product is equal to the product of the magnitude of A and the magnitude of B times sine of theta. Number 4, given two non-zero vectors A and B, A dot B is equal to the scalar 0 even only if A and B are perpendicular. So if A and B are perpendicular, then theta will be equal to power 2, cosine power 2 will be 0. So the dot product, the result here will be equal to 0. Vice versa, if A dot B equals 0, where A and B are non-zero vector, then the magnitude of A and B are not 0. The only possibility is cosine theta equals 0. And theta being from 0 to pi, theta has to equal to power 2. So A and B will be perpendicular. Now for cost product, A cos B is equal to the 0 vector, even only if A and B are parallel. When A and B are parallel, then theta will be equal to either 0 or pi. Sine of theta will be equal to 0. So the magnitude of the cost product will be 0, and so the cost product will be the 0 vector. Vice versa, if A cos B equal to the 0 vector, where A and B are non-zero, then these two magnitude will not be 0. The only possibility to get 0 is sine theta equals 0. When sine theta equals 0, theta go from 0 to pi, theta has to be equal to either 0 or pi. When theta equals 0, the two vectors will point to the same direction and they're parallel. When theta equal to pi, the two vectors will point to the opposite direction, and A and B are still parallel. Number 5, since the dot product is equal to this, then if the magnitude of A and B stay the same, then when theta is closer and closer to 0, then cosine theta will get bigger and bigger. So, which means that the more A and B point to the same direction, the bigger the dot product. On the other hand, for cost product, if A and B, the magnitude stay the same, when data is closer and closer to power 2, in other words, that the more perpendicular that A and B become, then the magnitude of the cost product gets bigger. And so sometimes we say that the dot product measure how much the two vectors point to the same direction, and the cost product actually reflects how much the two vectors point to different direction, like how perpendicular they are. Number 6. That product is commutative. A dot B is equal to B dot A. Cost product is not commutative. A cos B does not equal to B cos A. In fact, it is equal to the opposite of B cos A. Number 7. A dot B is equal to the product of the magnitude of A times the magnitude B times cosine theta. Now think about this part here. The magnitude B times cosine theta, which is this part here, or this part here when theta is bigger than power 2. And that's called the component of B along A. So the dot product basically is using the magnitude of A times this component of B along A, either this one or this one. When theta is bigger than power 2, cosine theta could be negative. So that product could be negative. So when theta is between 0 and power 2, think about the dot product as the magnitude of A times the magnitude of the shadow of B along A. And when theta is between power 2 to pi, think about the dot product of A and B as the magnitude of A times the magnitude of the shadow of B along A, but with the opposite side in front. So put a negative sign in front. Now for cost product, the magnitude of the cost product A cos B is equal to the area of this parallelogram determined by A and B. So we have compare and contrast that product with cost product. And here are the 7 main difference between that product and cost product. Thank you for watching, and I'll see you guys next time.